So hi, we have reached the last exercise, which is about a heap of prime factors. So we know that an integer number can be represented in a heap using its prime factors. So for example, we have here 2224. So if we multiply all these elements, we can have 24. So 24 we have decomposed it into its prime factors. So we have the function here which is called prime factors, that given an and it will print the prime factor. So we could use it in order to fill the heap with a number prime factor. So instead of printing the elements, the prime factor, we just need to add it to the heap. So we'll write it in a while, and then we need to return a number given a heap. So we have here the heap, so we need to multiply all these elements in order to have 24, and then we need to compute the GCD of two numbers represented in two heaps. So we need to check if it belongs, and we know that the GCD is equal to the common divisor. So we need to check if what we have in common between two heaps. So we have here the prime factor. So I have copied all the implementation of the heap, of a max heap. So we can check it in the lecture. And here we have the function that prints the prime factor. So I will copy it and place it here. So instead, so I will look, so let's skim it directly. So we have a number n, so we'll continuously divide the number by 2. So if it divides by 2, it means that 2 is a divisor, because 2 is a prime. And then we'll start from 3 and jump 2 at a time till we reach the square root of n. And if it's divisible, n is divisible on one of these I, it means it's a prime, and I will print it. And at the end, so we have where n is a prime number is greater than 2, so none of these will work. So I need to print n. So instead of printing n, I will just need to so I have here a heap, so I need to declare a heap. So this is a heap h. So as you remember, a heap it takes the type and the size. So at the first, size is equal to 1, and the type is a max heap. So because here we have the resize, so whenever we add more elements, more than one element, it will get doubled. So if you remember this, so instead of printing, I will insert into h 2 or is equal to I here. So insert. So this is where we insert an element into the heap, and automatically it will do the percolation. So either you place here I, or you can place 2. There's no I here, it's 2. And then we need to insert here the element I, and at the end here we insert the element n. So and at the end I will return the heap. So this is it. So as easy as that. So then we need to get the integer. So in order to get the integer, we need to multiply all these elements. So we know that the heap is an array, so we just need to loop over the array and to get to multiply all its elements. So we have I and number for the result. So number would be equal first h arrow array of 0. This is the maximum element. So this is one of the element, and then I will loop from I equal to 1, I less than h arrow count I plus plus, and I would place in NB equal NB multiple h arrow of array of I. And this is it, and I will return, of course, the number. So we have found the integer here. So let's continue. So next we need to find the GCD. So in order to find the GCD, I need to find, so if I have two trees here, so I need to look where's 2, if 2 is in the second tree, and if it's in the second tree, I will count it into the GCD. So for that I have the belong. So I have a number n, and I need to check if it belongs to the heap. So I need to check all the elements in the heap. So for int I, and for I equal to 0, I less than h arrow count I plus plus, and if the n here is equal to data of I will return 1. Otherwise, when I loop and I didn't find the element, I will return So GCD, I have two heaps, so I need to find the common elements between all and R, and I will multiply these in order to get the GCD. So again, I need a counter for the loop and number equal to 1, and then I will loop over one of these, for example, let's say L, and I will check. So if it belongs, so if L array of I belongs to R, so I will count it in the GCD. So number, it would be equal to number multiple L arrow array of I, and at the end I would return the number. So this is it. So in the main function, so we have here the output. So we need to enter a number. So first I will enter the number 24, and we will have the prime factors, which is the 3 here. So I will not draw it. So and then we'll get the number from the heap. So obviously we should get 24, and then we'll enter the second number, which is 16, and then we will find the GCD between 16 and 24, which will be equal to 8. So let's run and see what we have as errors. So we have here n, so we don't have nb, it's n. So again we have here h arrow data, it's at line 237, so array of I, there is no data. So okay, we have got the same elements, which is equal to 24, and the GCD is equal to 8. So it's an easy exercise how to use a heap. And again, thanks for watching, and if you have any questions, do not hesitate to write to me.